So this section, they title it Algebra of Functions. But what we're going to be doing a lot is function operations. And so we're going to look at like our 4 basic operations: add, subtract, multiply, divide. We're going to be performing those operations with like 2 different functions. So they're going to give me like an f function and a g function, and we're going to do some different things with those functions. And then sometimes we'll take that new function and we'll evaluate it, or we'll do something else with it. All right, so first up, if I were to give you, and this is how a lot of the problems are going to look today, f of x equals x plus 2, g of x equals x squared plus 1. Okay, and what you'll see here in a little bit is there's going to be some problems that are going to have like 7 parts to them, like part A through F, because we're going to do a lot of different things with like these 2 functions. So these are the 2 functions that we're going to be working with, and we're going to do a bunch of things with them. For this first example, I'm just going to show you a couple of different things we could do with it, and then we'll talk about some here in a little bit where we're going to do multiple things and multiple operations. All right, so on this one here, if I asked you to find f of 3 plus g of 3, that's something that we've done before, right? We're evaluating a function. We're going to take 3 and we're going to plug it into the f function. So 3 plus 2 would be 5. Then we're going to take 3, plug it into the g function. So this would be 3 squared, which is 9. And then 9 plus 1 would be 10. And 5 plus 10 would be 15. Okay, and that would be one way that we could get there. Another way that we could get there is to do f plus g of 3. And here's what I'll tell you. In some cases, we're evaluating it. In some cases, we won't. Some problems today are just going to say, what is f plus g of x? And we won't necessarily have to plug the 3 in. Okay? So in this case here, what we're going to do is we're going to do this first, because we're basically doing order of operations, right? So we're going to do the adding of the functions first, and then we're going to look at putting the 3 in. Well, what I'm going to show you here is f is x plus 2. I'm going to go ahead and put it in parentheses just because that's f function. And then we're going to add it to the g function. And the first thing we're going to do is going to combine these 2 functions together to make a new function. So we're going to combine like terms. I always like to put the x squared first. That's usually how you're going to see functions written. Highest exponent down to lowest exponent. We call that standard form. The x is the only x we have in here. And then 2 plus 1 would make this 3. So if I said, what is f plus g of x, that would be our answer, right? But then what we're going to do is we're going to take this 3 and we're going to plug it in for x. And now we're going to take 3 and plug it in all the way through here. So this would become 3 squared plus 3 plus 3. Which gives me 15. And it's the same answer that we have up here. Okay? And if I had to choose, the first way is no doubt the easy way to go. Okay? And I'm showing you both ways because I'm showing you that you could do it either way. Sometimes it may ask you to do f plus g of 3, but also know that I can just take 3 and plug them in separately and add it. But sometimes we're not plugging in a number, so that's why we have to know how to add functions. And so sometimes it might just say, what is f plus g of x? So we're just going to add those 2 functions together and leave our answer as some big long expression, whatever that might be. So that works with addition, that works with subtraction, that works with multiplication. Division's gonna be a little bit different, and some different situations. But I'm not gonna give you an example of each one of those at this point, but we will talk about all of the other operations as we go through. And I'm gonna show you one where we're gonna do multiple parts with the same two functions over and over again. Okay, so this next one I'm gonna show you, we only have 3 parts to it, okay? And then the next one's the one that's gonna have a bunch of parts to it. So each problem, when we start over today, is gonna state the 2 functions that we're using. And we're gonna use those same 2 functions over and over again throughout. So for part A, first one we're going to do, f plus g of x. Okay, now this one's going to look kind of weird because if I'm going to add these 2 functions together, I'm going to take the f function, which is x plus 1, and I'm going to add it to the g function, which is the square root of x plus 3. So as we look to simplify this and see if there's anything we can do to make this a little bit simpler, can I combine my x's together? What do you guys think? No, because this one's underneath the radical, okay? And because the radical's over the top of it, they can't be combined. They are alike, they're the same term, same thing with the 1 and the 3. Nothing we can do to it, right? That is all that we can do. And so it doesn't seem like we've done much, but that's your answer. That's your simplified expression. Sometimes there may not be a lot that we can simplify. Okay. All right, for part B, now it says f plus g of 6. So this kind of goes back to the one I did just a second ago. I could take 6 and plug it into each one of these and then add the 2 functions together, f of 6, g of 6, and then put it together. But because I've already done part A, in this case it probably would be easiest just to take 6, plug it into f plus g. We're just going to rewrite it as 6 plus 1 plus the square root of 6 plus 3. So this would be 7 plus the square root of 9. Square root of 9 would be 3. So 7 plus 3 would be 10. So sometimes we're evaluating, sometimes we're just leaving our answer as an expression. If I see a number in this spot right here, we're evaluating. If I see an x right here, then we're just simply leaving it as some type of expression. Okay, the third one on this one, very similar, f plus g of negative 4. Okay, f plus g of negative 4, once again, we've already done f plus g, right? We have that answer from part A. So a lot of these you're going to use maybe like a previous answer to help us answer one of the ones down throughout our parts. So kind of like we did on part B, we're going to put negative 4 in for x. So this would become negative 3 plus the square root of negative 3. Now what? What do you guys think? Can I combine the negative 3's together? Do I just leave my answer like this? What do you think? What are we going to do?
Why did it go? I might have missed some, but why did it go from like x plus 3 to 1 in the radical?
No, you're, yeah, where did I put the 1 at? Yeah, I copied the, yes, thank you, Armani. I saw the one there, so it should be a 3 here, right? Yep. There we go. Thank you. Now, it still doesn't change. We still have a negative here, right? Definitely a different number, but still a negative. What do we know about taking the square root of a negative?
Don't work.
Doesn't work, can't do it, okay? So anytime, for right now, anytime we see the square root of a negative, any negative, then we would say does not exist. Or no real solution, okay? Something along those lines. Okay, so here is an example, one of the big ones that I was talking about. I'm going to give you two functions. Okay, and I'm going to write out six parts here. For part A, and I don't like the way that sometimes they ask us to do this first. I'll show you what I think is the easier way of doing this, but I'm going to do it the same way. That is in the book. Okay, so we're also going to see some domain questions today. Once we get our new function, our new expression, whatever that is, we are going to look at that function and determine what the domain is. Okay? And I'll talk about some easy ways to determine that. Most of the time, domain's not as bad as what we might think in some cases. And so we just have to kind of determine like what type of function are we going to end up with and what would the domain of that function be. And you can, graphing is always a good option too. All right, so for part B, here's what I was going to say. Part A, I'm going to come back at the very end and do part A. I don't like that they list it first. If it was me, I probably would list it last because I like to know what f plus g is, right? Right now, I don't know what f plus g is. So I would rather know what f plus g is first and then come back and determine what the domain is. They just happen to list it first. So you may have to wait and do part A last. And so you don't necessarily have to do them in the order. And if it was me, I probably wouldn't. All right, so for part B, this is the one we've done a couple of times. F plus g of x. X squared minus 4 plus x plus 2. If you want to put it in parentheses, you can. You don't necessarily have to. We're going to combine like terms. We kind of saw one like this a few minutes ago. X squared, nothing to combine to it. X, nothing to combine to it. Negative 4 plus 2 would be negative 2. That would be our answer, f plus g of x. I'm going to wait, and we're going to do all these parts first, and then we'll come back and talk about what the domain of each one of these might be, all at the same time. All right, C, f minus g of x. This is one reason why I like using parentheses, because if you don't use parentheses, I think you're bound to make a mistake here. Because what we have to do is we have to subtract this whole thing, right? And when I subtract the whole thing, that means I got to take this minus sign and I got to distribute it through to whatever that g function is. If I don't put it in parentheses, I'm probably going to forget to distribute, which is going to change my answer and change my sign. The x squared minus 4, nothing's going to happen to it. But then we're going to go minus x minus 2. And then we can combine like terms. And we get x squared minus x minus 6. Okay. And you don't necessarily have to write it in standard form, but that's the way the answers are usually going to be expressed. So I'm just trying to get it to the form where we're going to go with the highest exponent first and then all the way down to the lowest exponent, ending up with the one that doesn't have a variable at all. Okay, so we've done addition, we've done subtraction. Subtraction, you got to really watch your signs. Okay, the next one is f times g of x. Once again, parentheses, I think, are pretty important here. And that's why I would like, I think it would be helpful to get in the habit of putting it in parentheses. This is something we haven't done for a while, but when I see these two things being multiplied together, what's that mean? What are we going to do? It's a FOIL, yeah. We haven't seen it for a while, but we should know FOIL, okay? It's a binomial times a binomial. So we're going to take x squared times x, which is x cubed, x squared times 2 minus 4 times x minus 4 times 2. All four of these terms are different. So that's my answer. First, outside, inside, last. Okay, fourth operation. Is division. We're going to take f divided by g of x. All that means is we're going to put f on top, g on bottom. In some cases, it may say g divided by f, which means I'm going to put g on top and f on bottom. Okay, so whatever is on top of the fraction is the function I'm going to put on top. So in this case, we're going to do x squared minus 4 over x plus 2. Okay, here's another thing that we have not done for a while. X squared minus 4. We haven't seen it for a while, but what can we do with x squared minus 4? What do you think, Ryan?
Take an x out of it.
Only if 4 also has an x attached to it. So that would be GCF, but you're on the right track. It is going to be factoring. What kind of factoring is x squared minus 4?
Square thing where you put x minus 10 over x plus 10.
Yep, we call it DOPS. Some of you probably have heard it as DOPS. Difference of perfect squares. They're both perfect squares, right? So we got to do a little factoring. We haven't talked about foiling or factoring yet this year, but those are things that are going to keep popping up, okay? Some of the skills that we've learned in Algebra 1, Algebra 2 that we're going to continue to see from time to time. So because x squared and 4 are perfect squares, x times x is x squared. One's a positive 2, one's a negative 2, and then on bottom, I have x plus 2. And then what's nice about this is I see that I have an x plus 2 on top and bottom. That may not always happen, but in this case, the x plus 2's can disappear, and we're left with x minus 2. Okay, one other one, I'll rewrite it down here. F is going to be, and this is another version of something that we can do. G times g of x. Rather than using both functions, f and g, this one only uses g and it uses it twice. So we're basically taking g times itself. And we know that g is x plus 2. So we're taking x plus 2 times itself, which would just be another FOIL problem. which like what we just did. X times x is x squared, and then 2x, and then 2x, and then 4, and then combine like terms. And there's our function. Okay, so just a little bit different variation. You could do the same thing with f. I could do f times f or any other operation with that as well. Okay. All right, one last thing then for this problem. It's kind of a doozy, right? Lots of different things going on here. We got to go back and we got to do the domain of those four, the four operation functions. Okay. Now it seems like that's going to be kind of hard, but here's why I like doing the functions first and then going back and determining the domain. On Monday or Tuesday we talked about all the different kinds of functions that we had, right? Quadratic and cubic and quartic. Well, we didn't do quartic, but we did square roots and some different ones like that. What kind of function is this going to be? Quadratic, right? I see the x squared. X squared is always quadratic, okay? What kind of graph does a quadratic equation always make? Parabola. And what's the domain of any parabola? All real numbers, okay? All real numbers. So we would just say negative infinity to infinity is my domain. Okay, f minus g. Once again, I look at my function. I see an x squared. X squared is my highest exponent. It's another quadratic equation. I can put it in my calculator if I really need to or want to, but what kind of graph is it going to make? It's another parabola, right? And what do we know about the domain of any parabola? It's all real numbers. Okay, the third one is a cubic, because my highest degree is 3. Cubic is one of those graphs that makes the snake-like figure. Okay, and that one probably doesn't look anything like this other than same kind of basic shape. But it's a snake-like graph. And so what would be the domain of something like this? How far left to right is this graph going to go? All real numbers. Yeah, it's going to keep going, right? So once again, it's all real numbers. The one that's usually the tricky one, or the one that usually has a different domain, is the division one, okay? And the reason why division is different is because we have a fraction and we have something on bottom of the fraction as we work throughout this problem, right? I know the final answer does not, but we got to go back to what we did right here because that's part of my solution. And what value of x would not work here? -2, right? -2 would make the denominator 0, and we've talked about how we can never ever have 0 on bottom, okay? If I end up with 0 on bottom, then we know something's going on, okay? So this is still all reals because this is just a linear function. It's all reals except for -2, okay? So what we're going to say here is negative infinity to -2, -2 to infinity. Another way that you could do this for a domain, and this is why I think they put it at the beginning, but I still like to do it this way. This original function is quadratic, right? This original function is linear. This one's all reals, and this one's all reals. So if these two are both all reals, then for addition, subtraction, and multiplication, they will also be all reals. The one that's always the different one is the division one because we have a denominator. Is there something that's going to make that denominator 0 is what you got to keep in mind. Okay, and so that's the one that makes it just a little bit different. Okay, any questions on that? So it's just a lot of parts, right? But we're using the same two functions over and over and over again. Okay, any questions on any of those? Okay, I'm going to give you one that's a little bit different, and we're not going to do all those parts to it, but I'm going to give you a couple of different parts. I'm going to give you this one because the domain in this example is a little bit different, okay? If I have f of x equals the square root of x, and g of x equals x minus 5. First one we're going to do, and we're going to do a couple of different parts here. F plus g of x and the domain of that. So we've done this several times today, but the one thing that's a little bit different here is we have a radical, okay? So we're going to do the square root of x plus x minus 5. When we saw one like this earlier, we talked about how we cannot combine anything together because this x is underneath the radical and this one is not, so we can't put those together. There's nothing here that can be combined together. So this would be my expression. So that's kind of the easy part. Now, the domain, what values of x are we restricted to? Okay, we can't have negatives, right? Because I can't take the square root of a negative. So what values of x would be okay here? 0 to infinity. Good. Okay? Because I can take the square root of 0, and I can take the square root of anything bigger than 0, but this square root sign right here is the part that makes it a little bit different for my domain. Okay, so as of right now, there's two things you always got to watch out for when you talk about domain. Denominators are a big one, right? We can't have a 0 in the denominator, and radicals. Those are the two things that are typically going to restrict our domain and give us something other than all real numbers. Okay? Those are the two that you really got to be on the lookout for. Okay, this time let's do f divided by g of x. Okay, square root of x is going to go on top. G of x goes on bottom. There is no way to simplify this, right? You can't just knock the x's out because you have a fraction. This one's a radical, this one's not. Even if this was just an x without the radical, you still can't knock those x's out, okay? So that's our simplified answer. And sometimes we're like, we've got to do more, but sometimes there's not. Sometimes you just write it out, write it as a division problem. That's as simplified as we can get. Seems like you should be able to do more, but you can't because of the functions that we have. So that's the answer for f divided by g. Now let's think about what the domain could possibly be here. And once again, you ask yourself, what values of x are okay here? Well, first of all, just like the setup here, it has to be 0 and above, right? But what about the denominator? Can't be 5, right? So it can't be negative and it can't be 5. And so when we write our domain here, we're going to say 0 up to 5, but we're not including 5. And then we're going to put the little u in here, and then we'll go 5 to infinity. And that would be the way we would express it in interval notation. You could say something like, if it doesn't say to write it in interval notation, you could say x is greater than or equal to 0, and x cannot equal 5. And I'm okay with something like that unless it says, let's write it in interval notation. And the reason why I keep going back to interval notation is anytime we have domain, especially if let's say it's a multiple choice question, they're going to express the answer in interval notation. That's the way the book is going to always go to anytime they talk about domain. And so we're going to keep seeing it. I want to keep writing it so we can keep thinking about it and we know what to do. So this one had both things that we talked about. It had a radical and it had a denominator. So that's not going to happen very often, but there's two things that make that domain change there. All right, so those are different operations with domain, doing a lot of different things. Okay, this last topic we're going to cover, this is going to be something completely new to you. We've never done this before, okay? Now, I'm going to explain to you what it is. So if you're like, well, what is the difference quotient, okay? And then I'm going to show you a really easy way to find the difference quotient, especially if we're given a linear function. And for college algebra, I'm going to just stick to linear functions for this. When you get into, if you take more math after this, like trig, then you might get into other functions or eventually calculus, right? And doing the difference quotient a lot. So this is kind of a calculus topic, but we're just going to really scratch the surface of it, okay? And kind of show you what's going on here. Okay, so difference quotient. Difference means subtraction, quotient means division, right? I'm going to write out what the difference quotient formula is, and I'm going to show you where that comes from. Because you're going to look at this and be like, what in the heck is all of this? Okay, and this is definitely a formula that you will be given. And when you first look at that, you're looking at it like, what in the heck is all of that? Okay, so I'm going to try to explain it to you. Where does it come from? Where does all of that derive from? And then I'll show you how to use it, okay? Difference quotient is really a fancy way of saying slope. Okay? Because if you think about your slope formula, we have the difference with a quotient, okay? We're subtracting and we're dividing. So that's kind of where the name comes from, difference quotient, okay? And I know how to find the slope of a line, right? But what happens if I have a curve like this, and I ask you to find the slope of it, okay? A little bit more difficult, right? We've never done that before. So here's what we would do. We would take 2 points on that curve, and we would find the slope between them. Okay? We're not going to use numbers here, and this is where it gets a little bit tricky, okay? We don't know how far over this is, right? But we're going over on the x-axis, right? So we're just going to call this x, because we're on the x-axis. And then to get over to this point, what we're going to say is we're going to add h units to it, okay? So like let's say here I'm at 2, and I add 5 more, then I know I would be at 7, right? But we're not using numbers like 2 and 5. We're using x to represent the first x value, and we're going to go over h more units, so we're going to say x plus h puts me here, right? Kind of like 2 plus 5, except we don't have numbers. So this x value would just be x plus h. Bless you. Just tells you how far over you're moving. So far, so good? Okay. Now the y value. Instead of using y, we don't use y's, okay? But what's another way to express y? How do we write like a function out? F of x, right? So we're going to say this right here is f of x. So this ordered pair down here is x f of x. F of x is just a fancy way of saying y. You could say I'm going over 2 and up 2. Okay, we don't know what the values are. We're just using variables to represent it. Okay, for this point right here, we know that x plus h is my x value. That's the first part of the ordered pair. Any ideas on what the y value would be here? If this was, let's say this was 7, okay? Then this number would be what I get when I plug 7 in, or f of 7, right? If this was 9, this would be f of 9, right? So whatever the x value is, I'm going to plug that into the function. And so this point right here is whatever I get when I plug the x plus h into the function. Okay, so here's where it comes from. We're going to do our slope formula with these two ordered pairs, just like we would typically do with slope, right? y2 minus y1. So we're going to do f of x plus h minus f of x. So if I were to find the slope here, I'm going to do f of x plus h minus f of x. And then on bottom, x2 minus x1. So we're going to do x plus h minus x. We can't simplify the top, but on the bottom, the x's can knock each other out. And that leaves us h. And that's our formula. Okay. So all we've done is slope, but with variables, right? So not necessarily fun part, because we're used to doing it with numbers. Here we're doing it with all expressions. Okay, I'm going to show you two examples here. I'm going to show you how to use with difference quotient, and then I'm going to show you a trick, okay? And remember, we're only doing linear functions here. I could give you quadratic, I could give you cubic, I could do all kinds of different functions here, but we're going to stick to linear functions, okay? And we're going to put this in to the difference quotient. So here's my formula, right? This is the formula. It's the same thing I put up above. If I said, what is f of 5? I take 5 and I plug it into this function, right? But here we're going to plug in x plus h. So x plus h goes in where the x is. So we're going to go 2 times x plus h minus 3. And then we're going to subtract the original function. The original function, f of x, is 2x minus 3. So we're going to subtract x minus 3. Okay? And then on bottom, we're going to divide by h. The bottom is the easy part. It's always h. Okay, so now we're going to use some of our algebra skills, and we're going to simplify this. We got some parentheses. 2x plus 2h minus 3 minus 2x plus 3. Okay, and for me, this is the fun part. And you're like, yeah, whatever, Mr. Ruda, fun, right? This is not fun. Watch what happens here, though. 2x and 2x, boom, they're gone. Negative 3 and positive 3, boom, they're gone. 2h over h, boom, they're gone. And we go through all that work, and we find out that the difference quotient is 2. But what did I tell you difference quotient is the same as? Slope. What kind of equation do we have right here? Y equals mx plus b, right? What's the slope of this equation? 2. The same as the difference quotient, okay? So, to make this, and this is where you guys are going to kill me, right? If I gave you this, and I asked you, what is the difference quotient of this function? What would you guys say? Negative 1/2. Okay. And I'm totally fine with that, okay? But I introduce you to it because this is something that some of you are going to go on in math, right? And you can go back and kind of remember that we've done this before, and this is where it comes from. And if I just said the difference quotient is always the same as the slope, yeah, you would get that, but you wouldn't understand why or how all that works, okay? So I am fine, like on a quiz or test, you don't have to show me all of that work. Just know that they're the same, okay? All right, once again, we're on the PDF. I don't know when I'm going to get books out to you. Probably not till next week. I got to have some time I got to number them and get them ready to hand out. So we'll see what kind of time I have. Okay. Not quite as many problems, but there are a couple of them that are the multiple parts, like A through F or something like that. So make sure you go to the PDF version as well.